Hi everyone, in this video, as promised before, we're going to look at when the polynomial goes through and when it turns around in terms of its graph at the root. For that, let's take these two examples. F of x is x minus 1 times x minus 2 and g of x is x minus 1 whole squared. Actually, let me add an x minus 3 and an x minus 3 to each of them. So over here, my roots are 1, 2, 3, and it's a cubic equation, right? So the end behaviors are here and here. In this example, I only have 1 and 3, but it's still cubic. So my end behaviors are still here, right? Now, x minus 1 squared whole squared, that's kind of like a quadratic, right? It's a parabola. Just keep that in mind. So for the left graph here, we're going to go through and go up. But for this one, we're going to go back and then through. So if you zoom in here, right? If you zoom, this looks like a parabola. And this is because we have x minus 1 squared and not x minus 1. Okay. So basically what this means is, it depends on the repeated zeros. The fact that x minus 1 is whole squared here means that 1 is a repeated root, right? There is only the intercept 1 is repeated because it's squared. So we can generalize this based on multiplicity is that if a root has even multiplicity, then if that's the root, it's going to behave like that. And if a root has odd multiplicity, then at that root it's going to go through. Okay, what is multiplicity? That's the power of the root. So for example, here my zeros are, so my factors, let's say, my factors are x, x minus 2 and x plus 1. And their powers are 4, 3, 2. These are what we call multiplicity. Now remember, these are all the same things. These factors correspond to the zeros at 0, 2 and negative 1. And based on their exponent, we have their multiplicity, right? Which means we can use that to plot this now. So we have 0, we have 2, we have negative 1. And we also have their multiplicity as being even, odd, and even. Now what about endpoint behavior? Endpoint, what's the highest? There's powers of highest power is going to be 4 plus 3 plus 2, which is 9, which is odd. So they have opposing behavior and there's no negative signs involved. So it's going to end up being up here and down here. Now at 4, because this is even, this is going to turn. This is going to go through and this is going to turn. So at negative 1, it turns. So I come in here, I turn. But I have to go back to 0. And then at 0, I turn again. and I have to turn to get to 2, but from 2 I go through. Okay, so instead of having a shape like that, I have a shape that turns 2 times because the multiplicity is even. Okay, so that helps us determine how it happens. Now, one thing you will observe here is because of, for example, because of the requirement that from -1 after it turns, it has to turn back to go to 0 and then back to go to 2, it creates these points which are kind of like local peaks. Now, this one is a local trough, and these could be thought of as local peaks. And these are called local Aximas and Minimas. So basically, if I have a polynomial graph, something like that, this highest point would be called a local max, and this lowest point would be called a local min. So it's basically where the graph is going to turn. Now you'll notice here that if there is, these are zeros, right? Between two zeros, there's always going to be one of these. So between two zeros, there is a max or a min. If you think about why that should happen, it's because once you have this 0, it's still going up. Now you have to come back here. The only way to get back here is to turn around at some point, and wherever you turn around is going to be your max. Similarly, once you are through, you have to turn around again. Wherever you turn is your min in this case. So the question is, how many min-max are possible for a degree n polynomial? Now let's see. Let's look at some examples. Right? If n equals 2, what are the shapes that are possible? I can have this or this, and there is 1 min and 1 max. If I have n equals 3, again there's a bunch of shapes I can have, but generally it's that, or as we saw, there might be turnarounds, but even with turnarounds, there's a max, there's a min, or there's a min, there's a max, or there's a min, there's a max. So here there's 2. So in general, we can say that in general, for degree n polynomial, at max, there can be n minus 1 peaks and troughs. Okay, that's because there is one of those between each successive pair of zeros. So if I have 1, 2, 3, 4, 5 zeros, right, there's going to be 1 because of these, there's going to be another 1 because of these, there's going to be 1 because of these, and then 1 because of these, for a total of 4. So, but that's the max one, right? Now note, it's not always n minus 1. That's the max. For example, if you take a simple example of x cubed, right, there's actually none here. So it can have 0, but it cannot have, for example, if it's a cubic, it cannot have like 4 or even 3 Maximas or Minimas. It's always going to be, at max, it's going to be 2 of them. There could be one, there could be, there can't be one, but there can be none, or there could be 2, okay? Why there cannot be one is not in the scope of this discussion, but when you are in Calc 1, we can talk about those things. That's all I wanted to talk about this week. So that's the end of that. And you can try the online homework as well as the worksheet. Okay. Thank you, everybody.